conditional. Okay, I'm going to start lesson 12. I hope it's lesson 12. So if you got your phone out, you should probably put it away to make sure you're staying caught up. We've got a few people at home. I have Teams open. Let me know if you have questions. Alrighty. So we finished yesterday with lesson 11B on user input. You're going to need that directly for the next assignment. So make sure that you finish that one. We have still only 10 of 22 submitted for assignment number 12. And only 14 of 22. So there are a few people in the class who are getting really far behind. I'm going to tell you right now that this class is not labor intensive. But if you put yourself in a position where you're so far behind that you can't get caught up, it's going to be confusing to you. You need to do the work to get caught up now. There's many people who are not doing that. Okay? So if you're still back at the beginning of this module here, if you're still working on assignment number 10, you should probably spend some time getting yourself caught up. All right? You don't want to put yourself in a spot where you have to do an entire module in 3 days. You're not going to be able to. I'll be able to tell, and you'll do poorly. So you've got to get to work on this stuff. Okay? Lesson 12, conditionals. So I have a video of me going through this as well, so you can watch that, or you can watch this video. It'll be there as well. Okay, conditionals are a way of comparing things. We've already talked about how we can use conditionals. We use them in Scratch with the if, then, else statements. These are the exact same thing. So if we start off with, we'll say print lesson number 12, conditionals. Then we're going to do something along the lines of print does 3 equal 3. So that is a basic Boolean question that you want to ask yourself, okay, or you want the computer to check for, all right? Does 3 equal 3? Computer would check that. It would return it as equal. Now, this is not an actual question. This is just a string. All right? So I'm going to show you how you would use that in the same manner. Now, our if-then statement changes, obviously, from Scratch to Python, but you can pull a similarity between them. So we're going to start with our if statement, and you can see it comes up blue. All right, so it's a keyword that you can use, and I want to use just regular numbers, and I want to say if 3 equals 4, and I'll put a colon at the end, and then I'm going to say print true. Oops. All right, so there's a few things going on here that are important to understand. First of all, the if statement, I'm getting an error in it. If I run it right now, I'm going to get that error statement. And it's going to say there's an error in line 4. This is where the line error is. And it even gives me a little error to this equal sign. The issue with the way I've written it with this syntax is that exact command is used for something else in Python. If we want to instantiate a variable, we say x is the name of our variable. We want to assign a value by saying equals 5. Now we've instantiated a variable. The computer can't tell the difference between me trying to assign a value to a variable and compare two numbers or two phrases or two strings or two floats or two booleans or two whatevers. It can't understand the difference, and I'm using the same command, a single equal sign. So if you are trying to use a conditional to get the computer to compare two things, you can't use the same syntax that we use to assign the value to a variable. All right? So in these situations, we use equals equals. That tells us that tells the computer, hey, I'm not assigning a value to a variable. I want you to compare these two things. All right? That's the first part. The second part is this colon. In Python, a colon means something on the next line is related to this line. That's the idea behind it. In Java, you'll use these all the time. Those mean you're at the end point of a command. No more information is coming forward. It's over. It's done. All right? The opposite for us in Python is that colon, which says expect something else. So when we use an if-then statement, we put a colon at the end of the if statement, the end of the conditional. Our option for carrying out the true report is always indented on the following line. And a Boolean is a keyword as well because it's a data type. So it comes up blue, and it's a capital T. You saw before when I had a lowercase t, I wasn't getting the right output. Okay, I can see a few people on their phones. I think I asked you to put those away. If you're incapable of monitoring yourself, don't bring your phone. You need to be paying attention to this. So this is now a functioning Boolean, or a functioning conditional. If 3 equals 4, print true. Now when I run this, I don't get an error, but I also don't get any output. Not getting any output is always dangerous because users are stupid and easily frustrated. So they run the program and nothing happens. That's about as aggravating and annoying as a program can be when it gives you nothing. Okay? So we have to account for that. First, I'm going to change my conditional. Whoops. I'm going to change my conditional so I can actually get an output. All right, so the computer comes to line 4. It sees the if. It knows it's going to be checking a condition. So it checks 4 equals 4. Computer says, yep, that's true. It goes down to the next line. Because the line was true, because the condition was true, it carries this out. And it prints true. Okay, hopefully everybody is still with me. There's one thing that I do want to address, and that is this indentation line right here. Now, if you watched when I did this, so when I was typing my condition statement out, I hit colon, and then I hit enter. It indented for me. All right? If it doesn't indent for you, you can tab over to the right spot, or you can push spacebar to go over to the right spot. Now, as you advance into more advanced coding, you can use one or the other. But just like the single quotation versus the double quotation, use the same thing through the whole code. And you do have a decision you need to make right now in terms of which one you're going to use, because there is a gigantic war going on in the coding world about using tab or spacebar. All right? In other languages that you would use, JavaScript, Java, all those other ones, you have to indent 8 spaces. So some people believe that you should push the spacebar 8 times, or you can push the tab 4 times, and you get that indentation that you're supposed to have. So anytime there's an indentation, some people believe you should push spacebar a bunch of times, or you should push tab less times. And it's actually quite a funny battle. I have this video right here to explain it. It's 4 minutes long, so I'm not going to watch it as a class right now. But when you go through this, feel free to watch the video. It's 100% comedy relief, but it is accurate in terms of things that coders believe. There is also a swear word in here. So if you don't like hearing swear words, don't watch this. There's only one, and if kind of half of it gets cut off, I thought about not putting it in, but you're all almost adults, and I think you can make the decision for yourself. All right? It's from the HBO show Silicon Valley. If you like coding and stuff like that, Silicon Valley is actually a very funny show for you to watch. And it's all about that. This clip is all about tabs versus spaces. So feel free to watch that one on your own if you want to. But you do have to make a decision if you're a space person or a tab person. All right? This page is done. Okay, so now we're going to compare integer variables. So we need to create two variables. Let's go with x equals and 3 and y equals 2. Is that what the lesson does? X equals 3, y equals 2. Okay, perfect. From there, we want to, again, like I talked about last class, we always want to tell the user what they're looking at. So we need to create something that does that. So we say is curly brace greater than curly brace, question mark, and quotation. And then when you use curly braces, you're going to use the dot format method. And inside, you're going to put the names of our two variables. Okay? And on an off-note topic, please don't use x and y as a variable name. That's a weak variable name. I'm just using it because I'm teaching the lesson fast and I don't want to have to think of cool variable names. Pick variable names that actually apply to what they do. All right? So we've done this one before. All this is explaining to the user what's about to happen. So we brought in these two variables. We gave them value. Now we're saying, hey, we're going to compare these two things. So is x greater than y? And it goes in order that they were introduced. So inside the brackets of the dot format, I put x first and then y. So it takes whatever the value of x is and inserts it into this curly brace, and it takes whatever the value of y is and puts it into this curly brace. So when we run it, it says is 3 greater than 2. Now, at least, the user knows what you're doing. And they're not going to get frustrated. All right? And that's very, very important. All right? So we start with that. Now we're going to put our if statement in. And we're going to say if x is greater than y, colon, enter, and it indents for me. Now I've already got an error. You can see the little red line. I've already got an error because it's expecting some action to be carried out if that above statement is true. All right, so I say if x is greater than y, print true. Now, all my errors go away, and I run it. So right now, x is greater than y. So when I run it, I get is 3 greater than 2? Yeah, that's true. And you can put other stuff in here too. You can put different phrases. You could put in, yes, 3 is greater than 2. Or you could put in, that is correct. Or the condition is true. Whatever you want to put in there. I'm just using the Boolean true for now. All right? Hopefully everybody's with me on that. I'm going to double check. I think that's everything. Now, I talked to you about it earlier. We want things to always be telling the user what's happening. If we leave our statement as it is right now, there can come a time when the user gets nothing. And that's what drives them crazy. So when I run this, it says, is 3 greater than 2? And then I get no output. Nothing. Now the user's frustrated. They're slamming their keyboard. They're screaming aimbot. They're doing all this stuff that users do when the thing they're trying to get to happen doesn't work. So you have to have output for the user so that they understand what's going on. All right? This is where we use the else. And you saw that in Scratch. You want to put that in so that the user knows. Okay? Now, else is its own. Hang on. That should be back there. Else is its own keyword, so it's going to turn blue when you use it. So we say else, and there's something coming on the next line, so we use a colon, hit enter, and then we say print false, if I could type, false. And you can see because this is a Boolean, we are getting the blue color for that because it's a keyword itself, it's a data type of its own. So if x is greater than y, print true, else print false. So the only time it prints this line is if this statement is true. If these two numbers are in a situation where the first one is greater than the second one, it will print this line. Any other situation, if they're the same, if they are if y is greater than x, then that statement is false and it will return false because it's the only other option available. So now, when I have this situation happening, I get true. If this situation is changed and they're now equal, I get false. I also get false if this number is greater. All right? Now we're in a situation where the user can actually function because they are getting the information that they need. Okay? And then you want to flip those around, back and forth, like I did. I changed the numbering here to make sure I was getting the right information. So if I put this one as 2 and leave that one as 3, I'm still getting false. Oh, I mean true, because x is greater than y. Questions? I think that covers this one. Okay, all I did here was change the values. Oh, no, I didn't. Okay, let's add this one in right here. And we're going to change the operation inside of our condition to greater than or equal to. So now it changes up how the computer is going to respond to the condition. So now the condition isn't saying just greater than, it's saying greater than or equal to. So right now, x is greater than 2, so when I run it, I get a true. If I change this to 4, I get a false. But now I'm also going to get a true if the two are the same. All right? It's basically the same thing. All you've done is added a second little operation into your condition. All right. Comparing strings. This is where we can start to get things somewhat interesting. We're going to create two variables. And those variables are going to be called player A. Sorry, one other thing I wanted to address. You can see in my if statement, my true result, or my true operation, is at the same indented level as the false. Now, it will still run if they're not in the same level, but because human beings have to look at these things, we want to make them format in a way that makes sense. So make those things always line up. Okay, so player A, we're going to call their value rock. Oh, okay. And then we're going to create player B, and we're going to say they are also rock. All right, and then from here, we want to use a condition that's going to check if either player A variable or player B variable equals rock. So we say if player A equals rock or player B equals rock, print somebody chose rock. All right, and this is another relatively important component to coding that everybody has to make sure that they understand. If player A is equal to rock, or player B is equal to rock, colon, indent, print someone chose rock. Okay, and that's the end of our statement. Now, there's lots of things that are going to happen here that I have to kind of run through. So first of all, it says someone chose rock. All right? So the value of the variable player A is rock, or the value of player B is rock. It's important to understand that this is different from that. All right? If I put a capital R for both of those and run my program, it doesn't return anything. It labels this condition false, because these two things are not the same as these things. They have to be exactly the same. And you have to be specific with your user to make sure that they enter those the same. All right? Now, this word right here, you can see the or turns blue. It's a key word that we use in programming. There's several different ones, but they're present in all languages. In Java, we use two straight lines to equal or. All right? What this is saying is that either A or B can be rock, and this statement is true. If the first one's true, the computer doesn't check the second one, because it doesn't matter. If one is true, then the entire statement is true. If I change this to and, now both of them have to be true. Because this one is asking that both A and B are true. So when I run this, I get no... Oh, because they are right. You're an idiot. So if I change this one to paper, now when I run it, I don't get an output. Even though this one is true, this one's false. Therefore, the and makes this overall statement false. If I change this back to an or, and I run it, now I get the output. Even though this one is not equal to rock, it doesn't matter because the computer stops once it finds 2. Okay? Hopefully that's making sense. I think I've explained all of this. Okay, so in order to accurately play a game of rock, paper, scissors, we'd have to be more specific with our code. We'll also have to use a new command called elif. Elif is something you can use if there's more than one option, or more than 2 options, or more than 10 options. And then there's a bunch of different ways to do this, but the elif option is one of the best ones. So if I say, let's say if player A chooses rock, and player B chooses a word I can never spell, scissors, okay, and player B chooses scissors, we want to print, so if we're playing rock, paper, scissors, who won? Player A or player B? Yell it out. Rock, paper, scissors, we know that game? Who won? Player A picked rock, player B picked scissors. Who won? A or B? Yell it out. A, thank you. Okay, so player A wins. All right, so if this statement is 100% true, we say player A wins. Okay, now we can add a second condition in there and say elif player A, I'll get it, player A equals rock, and player B equals paper, colon, next line, print, player, so if player A picked rock and player B picks paper, who won? A or B? Say it louder, please, thank you. B. So player B has now won, so we have the output say player B wins. Okay, so now we have two options in the game of rock, paper, scissors. We have player A picking rock, player B picking scissors. In that situation, we print player A wins. Now, so the computer checks this statement right here. All right, and it says, is player A's value and player B's value the same? Or rock and scissors? It's not, so it does not run this line of code. Because this is not true, it's false. It gets to line 22 and it says, oh, okay, I got another thing to check here. I'm going to check the value of A, it's rock. The value of B is paper. That's not true because right now they're both rock, so I'm not going to run this line of code. So now we can throw in our else, but we're going to put it at the right indentation. Else print tie. Now, when we run this, it's going to give us an output for no matter what happens. Okay, so right now it's a tie. If the first one's rock and the second one is scissors, and we run it, it says, oh, player A won. If we change it to paper, now it says, oh, player B wins. Okay, so it goes through that list and it checks, and it checks, and it checks, and it checks. The problem we run into here now is if we do this, it's still correct, because it's going to say tie. But if we change that to there, and we run it, it still says tie. And that's not accurate, because player A should have won that one. So in order to make this an actual full game of rock, paper, scissors, you would have to have all possible permutations of this game accounted for. And you can see it would probably make a rather long line. And I think if we go back to here, so I explained this one. This is not a true game of rock, paper, scissors, but it contains almost all the code you're going to need to create it. There's several steps missing. In a real game, there's 3 choices per player for a total of 9 different combinations per instance of the game of rock, paper, scissors. So there's 9 different examples. Right now, we've provided the computer with 3. There's still 6 more that we have to provide it in order to make, oh no, don't do that to me. In order to make it a full rock, paper, scissors game. Okay, that is the end of that lesson, but I'm going to go to the assignment here quick. I hope I didn't lose all that. Okay, good. Okay, so right now we've got 3 options, but we're going to need a total of 9 because there's 3 options per player. I don't remember my statistics very well, but I think if there's 3 options for 2 different outcomes, 3 times 3 is 9. That's how you get the total number of options that can come out. Okay, so if I go back to the assignment related to this one, lesson 12 conditionals, is assignment 13, rock, paper, scissors. So I've already done part of this for you. Oh, I didn't embed that one yet. My bad. Forgive me. I'll embed it right now. So if we go to rock, paper, scissors, I give you all the options that you're going to need to be able to figure out how to do it correctly. It's just, we got to make it a little bit harder. All right, so I already explained this one. In the real game of rock, paper, scissors, there's 9 options. 3 of those are a tie. 3 indicate player A win, 3 indicate player B win. Your version has to include user input for the choices and must account for every combination possible. So you're going to have a prompt that says player A, enter rock, paper, scissors. Player B, enter rock, paper, scissors. Then the computer determines based on your conditional statement who won. All right? If you want to randomize one, you can do that too. That's a little bit harder. But if you're ahead of the game and you want to challenge yourself, feel free to do that. These are all the options. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, if you feel like a challenge, address the following questions in the code. These are options that will most likely require code you haven't used yet. What if the user inputs a character that's not an option? So users being users, you'll ask them to input R-O-C-K, and they'll input R-O-K. What happens? Because that's not going to equal anything. So somebody's going to get a win they don't deserve. All right? Can you play multiple times and keep score? Can you play randomly against the computer? If you're ahead of the game and you're waiting, try figure out number 7. That would be the one that would probably be the most useful. Okay? How can you get player B to be a random choice? All right? And you'll have to play with some code you haven't used before in order to do that. Okay? This assignment is a little bit more challenging. So I am probably going to give you a touch more time to get that finished. Let's say today you only have half an hour left in this class. I think this is definitely a class assignment you'd need 3 hours for. Give me 1 second to fix this. Today is the 18th, so you have half an hour today, 2.5 tomorrow. I think by the end of class tomorrow, that could be finished. So that next lesson will be the 20th, which is Thursday. I think that's a fair amount of time for you to be able to do it, so we won't have a lesson tomorrow. But you have to have rock, paper, scissors finished by the end of tomorrow. There's also a quiz there, but I think as you figured out now, the quizzes are not real demanding. Okay, so quiz number 4 should be done by the end of class tomorrow. Whew, 32 minutes, 12 minutes longer than I like to go. Any questions about conditionals, rock, paper, scissors, the assignment, the quiz, anything like that? Anybody at home can use Teams if you have questions. Last chance. Going.